Hey guys, today we're going to be doing this chemistry problem. I'm just going to get straight into it. So it tells us for ammonia, the enthalpy, already telling me there's enthalpy. Enthalpy of fusion is 5.65 kilojoules per mole, and the entropy of fusion is 28.9 joules per Kelvin times moles. Will NH, then we'll go to part A, will NH3 as a solid spontaneously melt at 200 degrees Kelvin? This is asking you, it literally, like, the only thing important here is this and this, honestly. You don't need to know anything besides when they're asking this. They're basically asking you, is this reaction spontaneous? Now, clearly, in order to determine if a reaction is spontaneous, you can determine that with the sign of your delta G, right? Which is equal to your delta H minus the temperature times your entropy. And they're literally giving you a temperature right here. So all you're simply going to do here is plug in. So delta G is going to equal, I'm going to convert this to joules, which is 5650 joules, 5,650 joules minus the 200 they just gave me, the 200 times the 28.9 joules. I was gonna put the units, but I'm just not gonna do it. Which is approximately. This is also like, I'm not gonna do like round it down to the last dot, but 130 joules per mole. This is basically 200 times 30, right? We can make that connection, not exactly, but that's kind of the idea I got here. But whatever. Now, here, since G is negative, this means that for A, will NH3 spontaneously melt? The answer is yes. It will melt at 200, spontaneously melt at 200 degrees Celsius. Okay, now, they're asking you for part B. Part B is actually quite different, might I add. Like, it's kind of like, it's different. Okay, so for part B, they're asking you, what is the approximate melting point of ammonia? Now, when they ask you when a question is like this, melting point, boiling point, whatever it is, melting, we know that things melt here in 0 degrees Celsius. They start melting low. It's freezing the other way, going down, melting, going up, whatever. So for here, what you're actually going to do to solve for this is you set delta G equal to 0. So if delta G equals 0, this is how you solve for the melting point. Like, this is how you will solve for it. At the melting point, delta G equals 0. So let's say I have my reaction right here, right? If delta G equals 0, I can say that 0 equals the enthalpy minus the entropy times the temperature. But then I can also add that term over here, right? To say that the temperature times the entropy is equal to the enthalpy, which means that they're asking me what is the approximate melting point, which means that they're asking me for the approximate melting point. They want a temperature here, which means I want this, which means that, once again, the temperature is going to equal the enthalpy over the entropy. So don't let these problems scare you, when in reality they're actually like way easier than they need to be. They just like to complicate them with the words. But this is a pretty straightforward question, but whatever. 5,650 joules per mole. And I'm putting the units purposely here. 28.9 joules Kelvin times mole, which is equal to 196. And then my joules can cancel out, my moles cancel out, and I'm left with 100. I already wrote it. 196. The Kelvin, I bring it right there. And that is how you solve this problem.